All right, hi Haley. This is 8.5 angles of elevation depression. This is SOHCAHTOA stuff. This is exactly the same thing as what we were doing in 8.4, except it's a little bit of a story problem that they give it to you. So it's just how the information is presented, and then you draw a triangle, and then it's all fine from there. But we're going to talk about elevation versus depression, angle-wise. Yeah, the first period were like depression. Yeah, okay, different type of depression, kind of. All right, so here you go. This is, I always think about it in terms of, this is my arm, okay? I'm not an artist, so whatever. Draw this at the top of your paper. Here's my little elbow kink right there. There's my elbow.
What?
I don't know. I'm not an artist. Anyway, there's my elbow. Okay, so think about your arm, like straight out in front of you, like horizontal parallel with the floor, right? Okay, if I tell you to elevate your arm, you look like Hitler, right? Ha
Hitler.
I told them that this morning, and Luke says, wait, can you hold that there for just a second? I'm going to take a picture. I said, no, this is called an angle of elevation because I told you to elevate your arm. So elevation is from the horizontal up, okay? Now if I tell you to take that same arm, go back to horizontal, and to depress your arm, you're going down. So an angle of depression, depression. This is an angle of depression, okay? Now, the difference between this diagram and the diagram that they give you right here at the top is that you have two different horizontal lines. So let's talk about that for a second. This horizontal line that you have going across here, if we depress that down, here is my angle of depression, right? Versus you have a different horizontal line, this guy, whoop, the bottom one, and we elevate that up to make this angle of elevation, right? So in my diagram, I used the same, like, is it called a fulcrum?
What?
Fulcrum? Like, whatever. Anyway.
That sounds right.
Yeah. It's like a rotation, like a fulcrum and an axis and whatever. Anyway, so I used the same thing, but I was rotating it up and down. This one, they're using two different horizontal lines. Now, the beautiful thing about this is because it's in relationship to horizontal lines, all horizontal lines are going to be parallel. So like this line will be parallel to this one, yeah? Mm-hmm. Now, my angle of elevation, this guy right here, this angle, versus this angle will be the same because they are alternate interior angles, so they will be the same measure. So because they're parallel lines, because they're based on the horizontal, those two angles, if they give that to me in a question, I can use that to my advantage because those are going to be the same, okay, if I need to move that angle around. All right, let's go to the first example. Leah is meeting friends at the castle in the center of an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. From the park's brochure, she knows that the castle is 190 feet tall. If Leah is 5'5", wait, not 5'5", 5.5 feet. Okay, just FYI, 5.5 feet is how many inches?
6.
5'6" tall. Okay, but they went ahead and converted it already because we're not going to use 5'6". We're going to use 5.5 feet. But just to keep that in mind, that doesn't mean 5'5". 5.5 feet tall. Okay. They want to know about how far is she from the castle. So here we go. Here is my person. Here's my lady. Leah is her name. And she is 5.5 feet tall. So I'm going to go 5.5. Okay. I'm going to draw a better picture. Then we have our castle over here. Okay, not drawn to scale, so just don't hurt me. And the distance from here to the castle is what we're trying to find. We don't know that, okay? But we do know that the castle is 190 feet tall. All right. The angle of elevation from the eyeballs to the top of the castle is 38 degrees. Now, the problem with that is they don't measure 38 degrees, like they measure 38 degrees as this being 38 degrees. Do you see that? 38 degrees from our eyeballs straight up is 38. Is it 38? Yes, 38 degrees. Okay. So if I'm looking at this being my triangle, right here like that, 38 degrees. There's my 90-degree angle. And we're trying to find this X right here at the bottom. But This side, we're going to use that side, but it is not 190 feet.
Be 190 feet.
We would subtract the 5.5. So 190 minus 5.5 is 184.5. That's the amount that we're going to use. So they throw some kind of tricky things in there. So you have to be careful of that. And that's what we have. Now we just use SOHCAHTOA. So we use one of the trig functions. If you need to write them out, SOHCAHTOA. Okay? We're using 38 degrees. That's my angle. What is x in relationship to 38?
Adjacent.
Adjacent. What about the 184.5? Opposite. So which trig function do you use? Tangent. Yep. Tangent TOA. And we do tangent of 38 equals. Yep, that one goes in the top. 184.5 over x. Now, do you remember what we do if x is on the bottom? We switch these two around. We flop them around. So x equals the 184.5 divided by tangent of 38. And then we find the distance that is.
I got 236.15.
236.15? And they want to go to the nearest foot. So we would just say 236 feet. Okay, that's how far she is away from the castle. Is it feet or meters?
Feet.
Oh, feet. There's another one down below that's meters. Okay. Good, happy with that? So just a story problem beforehand. All right, example 2 has an angle of depression. We are doing a search and rescue mission, and we have people floating in the water. So here's what we have going on here. The airplane, they say the angle of depression down to this person that's floating in the water over here. The angle of depression is 42 degrees. Now, we said that if that is parallel to this line, then this angle will also be 42 degrees. You see how that works? Okay. We know that the person that's rappelling down is 18 foot here, and we're trying to figure out how far that person, after we drop them here, how far they have to swim to get to that other person. Is basically what we're trying to find. So, I'm going to draw this over here a little bit nicer without all the mess. We have a 42 degree angle here, 90 here. This is 18, this is x, and that's what we're solving for. And then we just use SOHCAHTOA. Okay, so in relationship to the 42, we've got x is 18, opposite is 18, and what's x? Adjacent. So this is tangent also, but this time it's tangent of 42, and this equals 18 over x. So we're going to do a little switcheroo again. We're going to swap those two values. X is equal to 18 over tangent 42. To the nearest foot would be 20 feet. Perfect. Okay, now.
When you use a marker, what happens if you
Well, then it says.
Stop, I don't do
you
that.
can erase that.
Okay, well.
Okay, now. Just to give you a little ACT plug here, okay, for those of you who are taking the ACT soon, you know that the solutions go in order, right? So let's say A is 5 feet, B is 10, C is 15, D is 20, E is 25. Let's say that those are the answers. And we don't have enough time to solve this problem, so we're going to guess. But we're going to narrow our answer down. All right, so let's take a look at this diagram. And this is 42 degrees. What will this top angle be? 48. 48. Okay, let's take a look at the opposites. So 42 degrees is opposite 18. 48 degrees is opposite x. It has to be bigger. X is bigger than 18, right? So we have just eliminated 3 of our answers, right? Now, 42 is pretty close to 48. So we know that x is larger than 18, but I would say it's probably just slightly larger and not like hugely larger. Like 25 is getting into like, that might be way too big range, right? So if I had to guess, I would guess 20 and we would be correct, right? So usually they'll give you answers on the ACT where you have at least 2, maybe even 3 that you can cross off right away that are obvious incorrect answers. And then you have 2 other ones that you like might have to choose between, whatever. So if we were crunched on time or didn't know how to solve that problem, Just look at the angles and we know that we can cancel some things off and we have a higher chance of getting it right. Good? Okay. Example 3. This is the last one on this page, and this is going to be like a bonus question. I'm probably going to give you a bonus question like this on your test. So, and there's one problem on your homework that will be bonus, but it will be based off of kind of this because it's a little bit of a complicated problem. So here's what's happening. Mrs. Long is standing over here, and she was originally standing right next to the tree. So here's what's happening. Mrs. Long is starting here, and she's walking backwards. She walks backwards just a little ways, and she looks up at the tree. And if you look up at the tree and you're like almost underneath of the tree, it's going to be a really high angle of elevation, right? 70 degrees is pretty high. And then she continues walking backwards to make another triangle, and she stops at about 10 meters, and she looks up in the air again. But now it's only a 26-degree angle of elevation. And she wants to know how tall the tree is. Woo, this is a lot of stuff. So I'm going to pick this apart, and let's write in the 2 triangles that we have going on here. Let's draw this one first. I'm going to do that in red. Okay, so let's pick apart that triangle. We'll draw them over here, just straight down below, and let's label that. So here's my 90-degree angle, assuming the tree is not like tilted or anything. We're just going to go ahead and assume that. And we know that this is a 70 degree, and we have, what do they call it? This X and this Y. So the distance, we don't know how far she originally moved back away from the tree. So we're going to call that Y. And then we have the other triangle, which is the overall one that's really big, but it's still a 90-degree angle. It's like the outside one, you know? Okay? But the deal there is that the X is still the same distance. So I'm going to try to make that the same height. And something like this. Right, something like that. So X is still here, 26 degrees now instead. But what's the bottom?
10 plus Y.
10 plus Y, yeah. Okay, now, the problem with doing these is that we have an X and Y going on at the same time, and we can't solve that. Because we have 2 variables. But let's just go ahead and set this up and see what we've got going on here. So I'm going to set up the green one, and then I'm going to set up the red one. If I do the green one, we have a 26-degree angle. What are the 2 sides in relationship to that? Opposite and adjacent. Okay, so we're going to use tangent, and we're going to do tangent of 26 equals, which one goes on top? X, right? X goes on top, and 10 plus Y goes on the bottom. Okay? Now, I still can't solve that because we have an X and a Y going on at the same time. So let's set the other one up, and let's see what we've got going on here. So we still have opposite adjacent, so we're still going to do tangent, but this time it's tangent of 70. And which one goes on top? X over Y, right? Okay, now, here's the deal. When we look at this diagram, the thing that remains the same from the one triangle to the other triangle is the height of the tree, right? The height of the tree is not changing. So if this is labeled as X and this is labeled as X, that means that they're the same height, right? So going over to our equation, we have this guy is the same as that one, right? So let's solve for X on each one. How do I get rid of this 10 plus Y? Let's multiply it to the other side. So times 10 plus Y and times 10 plus Y, okay? And that's going to give me X equals 10 plus Y times tangent of 26. Make sense? Good? On the other side, let's do the same thing. Let's multiply the Y over times Y times Y. So X will be equal to Y times tangent of 70. Okay, now what? Yeah, you can set them equal to each other. The x's are equal, so those things are equal. So we have, if we join them together, we have 10 plus y times tangent 26 equals y times tangent 70. Now what can we do? Yeah, this is a little bit confusing. How do we solve it? Jalen's picking up her calculator. Is that a calculator? Yeah? What can we do?
Can you just figure out what the tangent?
Yeah, we can do tangent 26 as a decimal, right? And tangent 70 as a decimal. So let's do those, guys. Whoop. It's really ugly. Yeah, give me like 3 decimal places. So like 0.488.
0.488.
Okay.
And then 2.747.
747. I think that's right. Yep, that's what we got this morning. Okay, so on the right side, we have 2.747 y. I'm going to put the y at the back. Okay, and now what do I do with the left side?
Oh, just distribute.
Distribute, right? If I take that times 10, I just move the decimal, right?
Yeah.
So 4.88 plus 0.488 y. Yeah? Okay. How many pieces do I have right now? How many pieces do we have?
3.
3. 1, 2, 3. We can put the y's together, right?
Yeah.
So subtract the 0.488 y minus 0.488 y. So we got 4.88 equals 2.2 something. 2.259.
2.259.
There we go. 2.259 y. Okay, now what?
55488. No. 4.2.
Divide by 2.259.
Oh yeah.
Yep. Okay, so y is
Wait, then we still have to go back.
Okay, fine one.
what is it? 2 something.
2.116.
2.16 is y? Okay. 2.16 meters. Whoa, that's what y is. We want x.
So,
Crud. So, I'm going to go over here. 2.16 is what y is. But we have 2 equations for x right here. We have that x equals 10 plus y times tangent of 26, or x equals y times tangent of 70.
let's do that one.
Which one? The second one? I like that because then we don't have to add 10, right? So all we need to do is take 2.16 times tangent of 70, and we have what x is. 5.934. Okay, 5.934 is x. But we're still not done.
What?
That's not the height of the tree.
Oh no, you add the 1.7.
Yeah, 1.7 is her height. So 5.93 is just the height above her. So add the 1.7 and we have a 7.634 or an 8 meter tall tree, because I won't think they want to round to the nearest meter, right? To the nearest meter. 8 meter tree. Woo, that was a lot of steps. Do you see why that's bonus? Holy cow, that's crazy. That's crazy. Okay, let's go to number 1 really quick. You will do, okay, so for homework, do all of them on both sides, except number 5 on practice is bonus. So all on both sides, but number 5 is bonus. Okay, but let's go to number 1, because they ask you some things and it's like we didn't do a problem like that. So number 1, it says name the angle of depression or the angle of elevation. I don't care which one you do. For number 1, we're going to do both of them just so that we can get an idea. Okay, depression, elevation. You can choose which one you want to do 4, 2, 3, and 4. You only have to do one of them. So naming the angle of depression. Which angle is the angle of depression? The top one, the sad one. The sad one. What? How do we name him? Angle what? Is that top angle? So FLS, right? FLS. Or you can name it SLF, right? So FLS, just as long as L is the middle letter, okay? The angle of elevation is this angle. So you can say TSL or LST, it doesn't matter. TSL. So that's all you're doing for 1 through 4, and then 1 and 2 on the backside. You're just naming the angles, okay? They fought with me. I thought you had to do the depression and elevation for each one. But Luke was like, no, it says or. Name the angle of depression or angle of elevation in each figure. And I'm like, whatever. So I let him have it. So I said, okay, fine. Just label one of them, whichever one you want to label. Because if you know one of them, you know the other one. So whatever. It's fine. So 2, 3, 4. Just name one or the other. But tell me which one it is, right? So you don't have to name one, but just tell me which one it is. Good? Happy with that? Okay. So there you go.
I'm still in your backpack.
All right. Everybody say bye, Haley.
Bye, Haley.